I am Srinivas, working as a chemistry lecturer in Sri Gayatri Junior College, SR Nagar, Hyderabad. I completed my MSc in SV University, Tirupati. I have 16 years experience. Today I am going to give the demo on electrochemical cell, which is part of electrochemistry. What is electrochemical cell? The cell which is used to convert chemical energy converts into electric energy is called electrochemical cell. Chemical energy converts into electric energy is called electrochemical cell. That means electric current produced by chemical energy. Electric current produced by chemical energy. The example of electrochemical cells are galvanic cell and Daniell cell. Galvanic cell and Daniell cell. In this galvanic cell or electrochemical cell, galvanic cell and electrochemical cell, two half cells are present. Two half cells are present. Left side cell is called, left side cell is called anodic half cell. Right side cell is called cathodic half cell. Cathodic half cell. What is the construction and the working of galvanic cell? Sir, later I will explain in diagram with diagram. So this part is one half cell, this part is another half cell. This left side half cell is called anodic half cell. Anodic half cell. At anodic half cell, oxidation takes place. Oxidation takes place. That means this is called as anode. So this anode is negative here electrode. This is here negative electrode. This negative electrode connected to positive terminal of the battery. Positive terminal of the battery. This right side half cell is called cathodic half cell. Cathodic half cell. In this cathodic half cell, cathode is present. Cathode is present. At cathode, at cathode, reduction takes place. Reduction takes place at cathode. This cathode is positive electrode. Positive here electrode. This cathode is connected to negative terminal of the battery. Negative terminal of the battery. Why this cathode is positive electrode? This anode is negative electrode. Because on electrolysis, negative ions are approaches to anode, positive ions are approaches to cathode. That's why this anode is called negative electrode. Sir, this cathode is called positive electrode. So for example, if we are taking copper and zinc, sir, zinc and copper as electrodes. In those, this copper acts as anode, zinc acts as anode and copper acts as cathode. Why this zinc acts as anode, copper acts as cathode? Because the reduction potential of zinc is less, the reduction potential of copper is more. The reduction potential which having less, that acts as anode, sir, which having more, that acts as cathode. Sir, that's why, sir, that zinc is act as anode, copper act as cathode. In this electrochemical cell, that zinc is dipped into zinc sulfate solution. that zinc is dipped into zinc sulfate solution. That copper is dipped into copper sulfate solution. That copper is dipped into copper sulfate solution. This zinc starts dissolving by loss of electrons. These electrons are here flows through external circuit. These electrons are flows through external circuit and reaches to copper In this copper electrode, in cathodic of cell, Cu plus 2 ions are present. Those Cu plus 2 ions gains those 2 electrons and converts into copper. So due to dissolving, this zinc is due to loss of electron. Sir, this zinc electrode is dissolved. Sir, due to gaining of electrons, sir, this copper is deposited on the surface of copper electrode. Due to dissolving, sir, this anode weight is decreases. Here due to deposition, the weight of copper increases. So what are the chemical reactions are here takes place, and these two half cells are internally connected with here salt bridge. What are the reactions here takes place in these here half cells? So at anode, sir, that zinc converts into here Zn plus 2 by loss of electron. At cathode, this Cu plus 2, sir, which is present in the solution, here gains these 2 electrons, here converts into copper solid. Sir, copper, sir, which is deposited on the surface of here copper rod. What is the overall reaction? Sir, what is your overall reaction? Zinc plus Cu plus 2 here gains Zn plus 2 plus copper. This is overall reaction of here this electrochemical cell. So next, what is the main use of salt bridge? This salt bridge made up of agar and strong electrolyte like potassium chloride, potassium nitrate and ammonium nitrate. Why these strong electrolytes are used in this salt bridge? So many strong electrolytes are present, but only we are using these 3 strong electrolytes. Sir, why not we are using remaining strong electrolytes? Because the transport number of these strong electrolytes are same. Sir, these transport number of these strong electrolytes are same. That means the transport number of K plus and Cl minus, K plus and NO3 minus, NH4 plus and NO3 minus are same. Due to that reason, we are using these strong electrolytes. So, and what is the main use of this strong electrolyte? Sir, to neutralize the charge, charge of these 2 half cells, we are using, sir, this is salt bridge. That is the main use of this one. And next is, for neutralization, ions are flows from one electrode to other electrode. In this anodic half cell, anions are, say here in anodic half cell, cations are more, in cathodic half cell, anions are more. For neutralization, sir, in this, cations are flows from anode to cathode. Sir, in this, anions are flows from cathode to anode. Sir, that means in salt bridge, here that due to flow for neutralization, ions are flows from one electrode to other electrode. So in this, here cations are flows from here anode to cathode. Sir, anode to cathode. Sir, anions are flows from here cathode to anode. So due to flow of ions, sir, these are neutralized. That ions are neutralized in, sir, both the half cells. Here this is your main construction of electrochemical cell. And next is, sir, how these half cells are represented. Representation of, sir, these half cells. Representation of your half cell. In this electrochemical cell, we are using salt bridge. That salt bridge is denotes with two vertical line. This salt bridge especially used to separate the half cells. To separate the half cells. Here left side of the salt bridge, radon anodic half reaction. Right side of the salt bridge, here cathodic half reaction. In anodic half reaction, the metal converts into metal ion. And cathodic half reaction, that metal ion converts into here metal. Those are separated with single vertical line. Single vertical line. Next, if any concentration is given, those concentrations are denotes with here written in the brackets bottom of the ions or electrolyte. That is here C1 and C2. This is here representation of electrochemical here cells. Next is cell potential or cell EMF. Cell potential or cell EMF. How can you calculate cell potential and cell EMF? EMF means electromotive force. Motive force is called as here EMF. What is your cell potential? The potential difference between cathodic half cell to anodic half cell is called as cell potential. The potential difference between these two half cells or cathodic half cell to anodic half cell is called cell potential. That means E cell is equal to reduction potential of cathode minus reduction potential of anode. Reduction potential of cathode minus reduction potential of here anode. That means that cathode is written right side of here, right side in the cell notation. That cathode is written left side on the cell notation. That's why this also written ER minus here E left. ER minus right side cell potential, reduction potential. EL means left side cell reduction potential of the cell. E cell is equal to E rate minus EL, or this may also be written E cell is equal to E cathode minus here E anode. E cathode minus E anode. By using this formula, we can determine your cell potential. By using this electrochemical cell, this electrochemical cell, we can determine cell potential, the difference between two half cells potential but not individual cell potential. For determination or calculation of cell potential, individual cell potential, we are using standard hydrogen electrode or calomel electrode. And next is, if both the concentrations are 1 molar, then only cell potential is determined. That cell potential is called as standard cell potential. Standard cell potential. If the concentration is changes, the cell potential also change. Due to different other than 1 molar concentration is given, those cell potential is varies. Those varying cell potential can be determined by using Nernst equation. By using here Nernst here equation, all those things are will explain here later. Thank you.